Okay, so welcome back. So let me tell you where I'm at now. And once again, this is the National NC-183, and I've successfully replaced all the capacitors, or the mica and the paper capacitors. As you can see, I use modern caps. There and there. My next approach will be to start replacing resistors. I'm not going to go ahead and measure them. I'm going to just go ahead and start replacing them all the resistors. And I wanted to take some time and just show you a little something that I found in this radio, and this is very interesting. This has something to go with soldering, and a lot of these radios are obviously built in the factories, and folks are soldering components. And I found in one of these band banks right here, I found that this silver mica, or I think this capacitor here, if you pay attention, let me zoom in, it's not soldered. It's just dangling there. See? And looks like the QA people, they tagged it and they marked it as soldered, but it's not soldered. Looks like it was pinched at the factory and it was set at the factory, but it was never soldered in. So with time, this will make contact, and I'm guessing once the rig gets hot, and this will not make contact anymore, and your frequency or your band will go quiet or read something else. So as you can see, this capacitor is not fully soldered, and this is straight from the factory. So this came up from the factory back in 1947. So this person who was using this receiver might have had this problem come and go as an intermittent problem, and he wouldn't have never noticed what it was. But as you can see here, that component was never soldered. It was pinched in there, put in place, but never soldered it. I mean, it makes good contact, but once it starts warming up, because it does get warm up in here, these contacts might open up and might loose and maybe just cause static or cause noise and not function. So just because it comes from the factory back in the day doesn't mean it's, sometimes you'll see errors from the folks who are soldering components. And like you can see, these components here, this is soldered, that's soldered really well. This is soldered, but not that. So what I've gone through every component, and this rig is just full of interesting solder jobs, interesting connections. There's a lot of connections that I'm going to fix that I'm not sure. These connections, these wires sticking out here, I'm not sure if the previous owner did something, but check this out. This is kind of funky. I don't know if this was like that from the factory, or the previous owner was modifying or doing something. Well, anyways, as you can see, I replaced all the micro mold capacitors, all these other paper capacitors. There's the electrolytic, another electrolytic right there, and I replaced that resistor. So I'm going to go through this and just start replacing the resistors. There's some of these resistors look kind of sketchy. I'm sure they're all out of tolerance. So as I go along and I start looking at things, I'm going to show you what I find. Show you what I'm looking at as I go along. Oh, here are all the capacitors, by the way, that this is the resistor I'm going to replace. But these are all the capacitors that I've taken out. And I'm going to start replacing the resistors next. This thing is loaded full of capacitors. The next video I want to do, I want to just for kicks, I want to just start measuring the current drain out of all these paper capacitors. And I have a capacitor leak tester that I made. All it is just a simple voltage power supply with a amp meter and a increased volts and the voltage meter, and I can just flip it on and read how much draw I have on each capacitor. So that's the next video, just for fun. I want to see what the drain on these capacitors are. So once again, I'm at it. Thanks for watching. I'll keep this simple and short. Thank you so much, and progress is being made. Talk to you soon. Thanks for watching. Bye.